Hello everyone and welcome to another online learning science lesson. My name is Teacher John and today we are learning more about heat energy. So let's look at our learning goals for today. Number 1, we will be able to describe how heat affects particles. And we remember that particles are the smallest unit of matter. Do you remember on our matter unit test, you had to draw the small particles? We just drew little circles to show the particles. Okay, so we are going to see if we add heat to the particles, what happens? Okay, and number 2, our second learning goal, we will be able to compare and contrast. That means to see how something is alike or different. We will be able to compare and contrast how heat affects different substances. So we are going to have a little demonstration today. Here is the link if you want to follow along. I will include it on the e-learning platform. Okay, so let's start by clicking our link. Great, and it opens up this website. We want to go down, down, down some more. Okay, great, until we get to this. It says States of Matter Basics. We want to click on this. It says phase changes. We will click on this. All right. And first thing we are going to do, where it says 14K here, we are going to switch that to minus 259 degrees Celsius. Wow, that is cold. You might be looking at this and you're totally confused. What is this? Okay, let's use our eyes and make some observations. So first question, what is this? These are particles. Particles of what? It is neon. We have 4 different substances right here. We have neon, argon, oxygen, and water. You can choose which substance you would like to play around with when you're doing this at home. But we are going to look at neon. Okay, so we look at this. Oh, it's so cold. Minus 259 degrees Celsius. Let's make another observation about the particles. Are they moving around very much? Are they moving everywhere? No, I don't think so. Do they have a lot of energy? No, they don't. So if we look at the temperature, that is how hot or cold something is. If we look at the temperature, it's very, very cold. Minus 259 degrees Celsius. So when things are cold, they don't have a lot of energy. What about if it's hot? So we see this bucket. We want to click this and push up and look at that fire go. Go, 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 go. More heat. More heat. More heat. Remember, this was at 259 degrees Celsius, minus 259 degrees Celsius. That is so cold. Okay, we added a bunch of heat. We are still at minus 180 degrees Celsius. But look at the particles. Do you think they have more energy or less energy? Are they sleepy little particles? No. So if we add more heat, we add more energy, the particles start doing what? Moving around, going everywhere. And we can look at these particles because we know about particles and matter from our last unit test. I think that these particles are moving around so much that this is a gas. Wow, so we added heat, the particles start moving, and it changed from a solid. If we go back to the beginning, you can see the particles are all lined up nicely. It's a solid. We add heat. Heat, 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 heat. More heat, and it'll turn into a gas. The particles start moving everywhere. Okay. So that was our first learning goal. We wanted to be able to describe how heat affects particles. I think that heat makes the particles move around faster. Okay, good. We got our first learning goal. Second learning goal. We will be able to compare and contrast how heat affects different substances. So we can go back. And remember, if we click up here, we can change our substance. I need to go back to Celsius. Okay, Celsius again. And here we are back at neon. The temperature is minus 259 degrees Celsius, so cold. We add heat. Just a little bit of heat. And wow, we are still at minus 234 degrees Celsius and it's moving around. What about water? Here we are. I'm going to bring the water down to only minus 193 degrees Celsius. Oh, so cold. What do you see? Is the water moving around everywhere? Nope. It is staying still. It is a solid, right? But at this same temperature, neon, even colder, only needs a little bit of energy. Wow. And it's already moving around looking like a gas. So I can see that some substances need more energy. They need more energy before the particles start moving. So water needs a lot more heat energy. Let's see if we can turn it into a gas. Wow, we're only at minus 77 degrees, still a solid. Keep moving. Here we are at 3 degrees Celsius. We can see that the water molecules are starting to move around a little bit. Wow, this takes way more energy to get moving. Over 200 degrees Celsius more energy to get this water moving. Let's keep going. 57 degrees Celsius, still not a gas, but it's moving around more. Moving. Here we are, over 100 degrees Celsius. Keep going, and we see, wow. Water didn't start moving around until we got over 100 degrees Celsius. If we look at neon, it starts moving around at minus 217 degrees Celsius. So again, we can see that water needs way more energy to get moving than neon. Wow, okay. So let's go back to our learning goal. we will be able to compare and contrast how heat affects different substances. So we had two different substances, water and neon. We saw that water needs way more heat energy. The temperature must be much higher before it starts moving around. Neon starts moving around at a very low temperature, minus 200 and something degrees Celsius. Wow, very different. Okay, so it looks like we accomplished our learning goals today. This website is so much fun. I want you to go on it yourself and try the different substances, oxygen, argon, all of that. And we can even go back and you can start playing with the pressure. Look, you can take the world's strongest finger and we put more pressure, more pressure, more pressure, more pressure, and oh, it can explode. Cool. So I want you to try that at home. I hope you were able to follow along with me, and I'll see you in the next lesson. Bye-bye.